What is the difference of squares in factoring polynomials? Imagine you're trying to simplify a tricky algebraic expression, and suddenly you notice something familiar: two perfect squares being subtracted. That's the key idea behind the difference of squares. When you see an expression like that, it means you can turn a complicated polynomial into a simple product of two binomials. A perfect square is just a number or expression multiplied by itself. For example, x2 is a perfect square because it's x times x. The number 9 is a perfect square because 9 equals 3 times 3. Similarly, 16y2 is a perfect square because it equals for y times for y. The main thing to look for is an expression that looks like the subtraction of two perfect squares. For example, if you see a 2b2, you can factor it into two parts, a plus b and a b. This is called the difference of squares formula. It works because when you multiply these two binomials, the middle terms cancel out, leaving you with the original difference. Let's look at an example. x2, 9. Since x2 is a perfect square and 9 is a perfect square, you can write it as x2, 3, 2. Using the difference of squares rule, it factors into x plus 3, x3. Another example is 9x2, 16y2. Both are perfect squares because 9x2 is 3x2 and 16y2 is for y2. So it factors into 3x plus for y, 3 for y. It's important to remember that this method only works when both terms are perfect squares and they are separated by a subtraction sign. If you see addition instead of subtraction, this method doesn't apply. Sometimes you might need to rewrite parts of the polynomial to recognize the perfect squares. For instance, for x2, 25 can be seen as 2x2, 5, 2. Once you see that, you can factor it into 2x plus 5, 2x5. In more complex cases, you can apply the difference of squares repeatedly. If one of the factors after the first step is still a difference of squares, you can factor it again. This process continues until no difference of squares remains. Knowing how to spot and use the difference of squares makes factoring polynomials much easier. It helps you break down expressions quickly and is a handy tool in your algebra toolkit. Remember, whenever you see a subtraction between two perfect squares, you can always write it as the product of a sum and a difference of their roots.